as there seems not to be any rush in, so I think I can start. So my name is Esko Tahkola, and I do come from CIDRA Minerals Processing, and my topic here today is to talk about particle size measurement from single hydrocyclone overflows. CIDRA cyclone track PST is the product. But let's first take a look at the typical grinding circuit. So you have, of course, the incoming ore with its all its variations when it's coming there. Then you have the recycling load coming in, and then you use the process water also to control the product there. In addition to that, you have the variations of level in the sump that is feeding there, and if the level is changing a lot or if the sump is small, you will have also variations in the air content of the material pumped forward from this. These ones we can measure with the CIDRA sonar tracker device that is capable of measuring both the flow and the volume occupied by those bubbles, and then do the correction for the volumetric flow, and after that also simultaneously online to the density measurement, so that you will get the real production rate there captured and controlled and stabilized. Then the particle size measurement part is the PST one that is installed in the overflow line, where the materials are hitting this sensor and the impact is interpreted as the particle size. Based on this, you will get a real-time online data all the time from the particle size, how it's behaving, and that is then the basis for the automated control of the total grinding stage. Based on this, you can optimize the tonnages and mill energy uses for produced tons. So simply, let's move to the presentation itself here. Ooh. So, particle size is definitely known to be an essential thing to optimize the production, so the tonnages and the recovery in the process. Although there is already a variety of near-linear particle size measurements, the problem is obvious still there, because relatively few concentrators are using automated controls on these stages. Particle size tracking PST from CIDRA is a truly online measurement that enables also availability of this measurement data up to 99% of the operational time. Real-time producing measurement results in every 4 seconds. Installation is very easy. You just drill a 2-inch hole there and put the sensor in. And that's how the whole system looks when a battery is instrumented. So every hydrocyclone overflow is having its own sensor. They are connected to a junction box that collects the signals to the PST computer, and that is then linked to your DCS system, so and customer DCS is available there. In addition to that, there is a cloud connection available, and CIDRA expertile support available for this. The probe is inserted through the wall, and the particles simply hit probe, and this impact of the generated by the particles is then interpreted as the particle size. Of course, to calibrate this, you will need to take samples with the actual variation range of the process operational conditions, and based on that you create a model for this, and when that is done you can utilize that model that aft. Of course, the probe will wear with time. Our experience is roughly 12 to 18 months is the lifetime of this kind of sensor. But you don't need recalibrations if you change the sensor. You just take it out, very simple and short action. This is how probe calibration typically looks like. It would be preferable that this calibration sampling would be taking place at a broader range than the typical optimized operational point only, because the wider is the range, the more accurate is the model. Of course, the accuracy is also improved by the number of samples, and of course it's affected by also your lab reference accuracy. So that's the total sum out of those. Let's look at the value assessment. So to make this kind of investments, you need some kind of evaluation method for the payback of this. And here we have one model that we have found to be very simple and very reliable also on this. So this evaluation methodology is based on usage of daily operating data from a mine over a long enough period of time, even up to 1 year, to obtain this kind of general plant operating performance. We need the information of throughput, recovery, and also the ore grade, what it is, to define this net mineral, what we get out of there. So the head grade is needed there. So the net metal production is just the head grade times tonnage times recovery. Very simple calculation. And to define that, we have in this model then included both the tonnage, so the optimization of a production rate, maximization of that, and the recovery is also there included. Of course, you have to take some plant constraints into account if there is a maximum limit for the tonnage flow or flow rates for slurry transport and things like that. Those have to be taken into account, and they might limit this maximum net metal production values that at least to be obtained occasionally. It's very simple, straightforward, and representative method to evaluate the investment paybacks than other methods that very much rely on samples collected from the process, because those number of those samples must be very, very high to create reliability. What is needed as an input plant? We take an example from a copper ore grinding flotation installation, and there we need to have ore throughput rate. Then we need to have the ground product reference size, so for example a P80 value or plus 65 mesh, like in this case is used. And after that you need the total copper head grade available and the recovery information of that. And those will allow you to calculate this net metal production of the line. If you look at the data, there are of course different kind of days on the plant, so there are some constraints running and affecting the data over a longer period. So it looks quite cloudy if we take this tonnage versus product size correlation here. So the correlation is not so clear if you look at the base data. But if we use a technology of data binning so that we collect sample groups there, first we have to eliminate this kind of clearly off valid data. So for example, when there's been production time losses during a day and that kind of data, those should be removed. But after that, we can do this binning. And by this binning, we create the binning averages, and then by doing that correlation over those binned results, average results, we will get far better and describing result out of that describes how the throughput is behaving as a function of the particle size. And as expected, we can see the throughput increasing with when the particle size is increasing. The same binning shall be done also for the recovery data, and we also get out from that as a result this typical curvated feature as a function of the particle size. Now when we combine these two data for the net metal production, for example in this case, we saw that the evaluation period resulted to be the average grind size resulted to be 18.4% over that plus 65 mesh, and that generated a net metal production of 18.7 tons per hour of net copper for a nominal head grade of 1% of copper. So if we combine this to maximize the net metal production, we can see that by sacrificing a little bit on the recovery side in advantage of throughput, we can increase the net metal production quite significantly. And in this case, the value of that would be that it could be set the optimal point for net metal production would be set to the 23.2% over 65 mesh, and that would reach 19.4 tons per hour of net copper, which is 3.8% increase in the net metal production, which already gives a significant payback for this kind of investments. So with this PST, we can squeeze the variation of the range in the process to much sharper and keep it controlled there. And that is what is gained by the utilization of PST particle size measurement technology and applying it to these processes. Of course, when you squeeze the variability like this, it means also that overall process variability is decreased. So the process totally runs much more stable. So there you surely will get additional gains in production. So the conclusions are that the availability of the reliable real-time product size measurement is the key for the optimizing the control of the grinding and classification systems, especially in those cases when the downstream stage is sensitive to particle size. Of course, that means mainly flotation. And PST is proven to provide true online particle size information, which is once incorporated into the overall process control strategy. It allows for the continuous attainment of maximum potential process benefits. This described value assessment methodology relies exclusively on the existing plant scale data and does not involve the execution of any cumbersome, time-consuming laboratory work. That 3.8 percentage increase estimate in this calculation in net metal production is very consistent with those experiences of the results that we have from these existing PSD installation. So the payback of the investment has been very fast. Thank you for your attention. For questions, I think I might have a couple of moments. Yes, lady there. It is actually calibrated against your laboratory. So we create a model out of this impact. So the impact is generating actually an acoustic wave with a wide spectrum. And we interpret that as this particle size based on the reference data gained from the samples that we take directly from the outlet of the overflow pipe there. I think that the velocity is not very extremely important in this case because we are typically installing on this free falling section of the flow. So it's not essential part of this. Essential is that the particles are separate, so that they are not as bunches of combined together. That is more important. Yes, John. Yes. Mm. Yeah, there will be a tiny difference there, but those kind of situations should be included in the when we create the model. So then you will have your ore with all these particles that are available there. If you totally change to a new ore mine, you are bringing a totally new type of ore in, then the recalibration has to be done. But if you include all those situations what you have in the calibration model creation, then the model is valid for all possible production what you have there. Yes.